All right, we're moving on to page 33. This is page 33, changes in matter. So we talked about solids, liquids, and gases and how they can change back and forth to each other. Now we're going to talk about some other ways that matter can change. Let's start with physical changes. We kind of went through some physical and chemical changes in the lab you did last class. We're going to do a little more in-depth coverage right now. A physical change is a change in the form of a substance, but not in its chemical composition, basically meaning not in what it's made out of. Not what it's made of. The identity of the substance does not change. So a physical change can be a change in size or shape. It can be a change in form or state. And you could also see something dissolving or separating. Those are physical changes. I'm going to actually add a bullet here that another type of physical change is an expected color change. Like if you mix red and yellow, red plus yellow, and you get orange, you expect that. That is probably a physical change. You know, like if you mix together mustard and ketchup, you're going to have something that has properties of both mustard and ketchup. You're going to have something that was red and yellow. It's going to be orange. In a physical change, the reactants and the products are equal to each other. And I've got some examples. For changing size and shape, you could have something be malleable or ductile. Malleable means that you can take, usually this refers to a metal, but it could also be clay or stuff like that. Things that are malleable are things that you can reshape any way you want. Specifically, if it means specifically you can hammer it into thin sheets, but it tends to get an alternate definition of just being something you can reshape however you want. Ductile means you can stretch it into a wire. Other ways you can change size and shape would be like cutting, slicing, or breaking. When we talk about changing form or state, that would be phase changes. Like what we were just talking about on page 31. And then, of course, talking about dissolving or separating. Dissolving, you know what dissolving is, but an example of the separating would be filtration. That's a way to separate stuff, and also something called distillation. That's another way we can separate stuff. Filtration, we are planning for you to do a lab with filtration in a few days. Even if you don't get to that lab, you did some filtration in the physical and chemical changes lab when you filtered your milk and Red Bull mixture. Distillation is what they do to distill or purify liquid mixtures usually. So you can go to the store and buy a jug of distilled water, which means that they basically took some impure water, they boiled it, they collected the steam, they recondensed the steam, and then they had more purified water without like a whole bunch of like minerals or bacteria or anything in it. That's physical changes. Oh, sorry, I didn't realize I was off screen there. Here, filtration and distillation. There you go. So those are physical changes. Let's talk chemical changes. Chemical changes are the changing of one or more substances into another substance. The identity of the substance does change. You get a new thing. So some signs of chemical change are, please excuse coughs, sneezes, and burps. That's a little memory trick. It's called a mnemonic device, where please excuse coughs, sneezes, and burps, the first letter stands for something. So please, the P stands for precipitation. And I know when you hear that word, you think of rain, but in chemistry, that word means that you make a solid out of stuff that wasn't solid before. You suddenly have a solid. So like I could mix together two liquids with each other and suddenly there's a solid. That's precipitation. That's what happened when you mixed together the milk and Red Bull. This is a new vocabulary word that you need to know what it means. Precipitation, that means you form a new solid. The E stands for an energy change. It could get hotter or colder. You could also see fire or light. Those are the most obvious. There are other ways, but those are the most obvious that there's been an energy change. Let me zoom in a little more because I'm writing smaller here. So please, the P stands for precipitation. That's a new word. You need to know it means it forms a new solid. Excuse, the E stands for an energy change, meaning it could get hotter, colder. It could get, there could be fire, there could be light out of nowhere. Coughs, the C stands for a color change, and this would be an unexpected color change. And we'll talk about what that means when we get down to the examples below. Sneezes, the S is for smells. If there are new smells or smells disappear, or there was one smell and now there's a different smell, those are signs of a chemical change. And then the burps, B is for bubbles. Or you could also say fizzing, or just general gas formation. And I think there were a couple different stations in the lab you did last class where you saw some bubbles form. Again, when there was nothing else that should have been causing it. If suddenly you have bubbles or a gas or some steam or fizzing or whatever, that tells you there's a chemical change happening. In general, chemical changes happen when a reaction occurs. Your reactants and your products are not equal to each other. You do not have the same thing at the beginning as what you had at the end. Some examples of chemical changes would be burning, also called combustion. Decomposition is a type of chemical change. And another one is oxidizing. That's a fancy way of saying, well, that can mean a lot of stuff. Right now, we're going to say that it means rusting. But there are other ways things can be oxidized. And then, of course, when we talk about unexpected color changes, that would be like, for instance, if I mix together a clear thing and another clear thing, and suddenly I've got something yellow. That's an unexpected color change. That tells me that a chemical change is happening. Or if I mixed together red and yellow and instead of getting orange I got purple, that would be unexpected. That would tell me a chemical change was happening. Some other examples of chemical changes would be if you have a new state of matter forming when you mix two things together. So not like I'm boiling something and I went from liquid to gas, but a new state of matter, like I mix together a liquid and another liquid and suddenly I have a solid. And one more example of a chemical change. Let's go with, let's see, we did burning, decomposition, oxidizing. Let's go with formation of light. If you mix together two things and suddenly you get light, that is showing you there's some kind of chemical change happening, like a glow stick. If you, you take a glow stick and you snap it, when you snap the glow stick it starts glowing. When you snap it, what happens is there's like a tube inside the glow stick with one chemical in it, and then floating outside that tube is another chemical, and when you snap it they're able to mix and they give off light. Well, the fact that when they mix they gave off light, that tells you a chemical change has happened. Let's talk about how we can write changes of matter in an equation. A reactant is what we call a substance that exists before a change. It is on the left side of what's called the yield arrow in a reaction. A product is a substance after a change, and it is on the right side of the yield arrow. Now, this is a word we are learning on the third day of class, and you have to know these words all year. Reactant and product. Reactants are on the left, it's at the beginning. They are the things that will react. Products are the things that are produced, so they are after the change, they're on the right side. It says circle the reactants and square the products in the equation below. Reactants are the things before the change on the left side of the yield arrow. This thing right here, that's called a yield arrow. Right there. That word yield, it's not like when you're driving. It means makes. Like if you have ever cooked, a recipe might yield 2 dozen cookies or something. Or yield 8 servings. When we use the word yield in chemistry, we mean makes. So this thing is called the yield arrow. And on the left side are the reactants. So if we're going to circle the reactants, then that's this and this. And if we're going to square or box the products are after the change on the right side of the arrow. That's this and this. And when you're done writing that, you can turn the page. We're going to do a little bit of guided practice. I'm going to walk you through a couple of problems here on these next couple pages. It says to identify each of the following as a physical change or a chemical change Then explain why each is a chemical or physical change using complete sentences. Put a circle around the reactants and a square around the products if applicable, meaning if they give you a reaction, circle and square the reactants and products. So a popsicle, which is basically water and sugar, melts in the heat of the Texas summer. At the beginning you have water and sugar. This is glucose, right? C6H12O6. And those are reactants, so I'm going to put a circle around the reactants. Here we go. And a square around the products. My products are also water and sugar. So I'm putting a square around my products. If you notice, at the beginning I had water as a solid, and at the end I have water as a liquid. At the beginning I have aqueous or dissolved sugar and sugar, glucose and glucose. So it asks, does the identity of the substance change? If I have water and glucose and I still have water and glucose, then the substance has the same identity. It did not change. And if the identity did not change, that is a physical change. When we explain, we need to use complete sentences like, this is a physical change because the identity of the popsicle does not change. The popsicle melts going from a solid to liquid, which is a change in state, or you could say a change in form. Looking at number 2, you burn magnesium and oxygen using a Bunsen burner flame to form magnesium oxide. Again, we have a reaction, so I'm going to circle the reactants. I'm going to square the products. And looking at this, I've got magnesium and oxygen. And at the end, I've got MgO, magnesium oxide, which, remember, this is an element, I know, because there's only one capital letter. This is also an element, I know, because there's only one capital letter. Here I've got 2 capital letters together. This is a compound. So I started with 2 different elements. I end with one compound. Does the identity change? Yeah. A compound is different than an element. The identity definitely changed, which means this is a chemical change. So I write in my complete sentences, this is a chemical change because the identity of the magnesium and oxygen did change. The sign of a chemical change we observed is blank when blank. There's a couple different ways you could word this. But if you go back to our, please excuse cough, sneezes, and burps, what did we see? We did not see a precipitation. We don't know anything about a color change, smells, or bubbles, but if you're burning stuff, your burning stuff is going to be an energy change. So the chemical change observed would be the energy change when, you could say, when the magnesium burned. Okay, these are 2 examples that I've done. If you need more, Ms. Woodlock can do 1 or 2 with you, but there are 2 more problems on this page, and there's 4 on the next page, and you should be able to do those 6 problems more or less by yourself, or at least without help from me or Ms. Woodlock. So what I actually want you to do now is go to your stamp page. Go to your stamp page. And today, again, depending on if it's an A day or if it's a B day, today is either the 28th or the 29th. And your stamp for today is going to be to finish page 34 and also the next page, page 35, basically those 6 problems. If you want full credit and you want this 4-point stamp, you're going to have to make sure that you do not only circling your correct answers, circle your reactants, square your products, whatever. You need complete sentences for your explanations. If you don't write complete sentences, you're not going to get that 4-point stamp. You're going to lose points. So keep that in mind, and I will, at this time, turn it over to Miss Woodlock.